Hello everyone. Welcome back to this session on 8086 instruction set. Already we had two parts of instruction set of 8086. This is the third part and going to be the final part of instruction set of 8086. Already we have discussed about the data copy or transfer instructions in part 1, arithmetic and logical instructions in part 2. We are going to discuss the remaining branch, machine control and flag instructions here. So if we take branch instructions, we have unconditional branch instructions as well as conditional branch instructions. So here a few unconditional branch instructions are given. First is a call instruction. This is used to call a subroutine or a subprogram or a procedure from a main program. So address of the procedure may be specified directly or indirectly. Then return instruction. This return is normally used at the end of any subprogram or subroutine or a procedure. The return instructions must be executed at the end of any subprogram or subroutine or procedure. Next is interrupt type N. When interrupt N instruction is executed, the type bit N is multiplied by 4 and the contents of IP and CS, that is instruction pointer and code segment register of the interrupt service routine, will be taken from the memory block into 0000 segment. So interrupts has to be given the priority at that time. Then next is INTO, that is interrupt on overflow. When an overflow occurs, when an overflow flag is set, then the instructions to be executed has to be carried out. Then unconditional jump. We have conditional jump instructions too, but simply a JMP denotes an unconditional jump. That is without any condition, just we give some address, we'll ask to move to that address. This instruction unconditionally transfers the control of execution to a specific address. Then is IRET, return from ISR, that is an interrupt service routine. When this instruction is executed, the values of IP and CS, that is instruction pointer and code segment register. See, always instruction pointer is a pointer register which is related with the code segment register. And flags are retrieved from the stack to continue the execution of the main program. So whenever an interrupt is executed, the last line should be IRET, and once after execution of IRET, it returns back to the main program. RET, we know RET, that is execution of subprogram. IRET will be execution of an interrupt. Then loop, it is unconditional looping. This instruction executes part of the program from the label or address specified in the instruction up to the loop instruction, CX number of times. Then we have many conditional branch instructions. We have 9 flags. We have a flag register, 16-bit flag register. Out of the 16 bits, we have 9 flags. 3 are control flags and remaining are conditional and unconditional flags. Out of this 16 bits, 5 are undefined flag bits which can be used for any other purpose when any extensions are being done. So conditional branch instructions based on the flags. The flags are carry flag, zero flag, parity flag, auxiliary carry flag, then sign flag, and what else is there? Some overflow flag. These are the different flags available in 8086, and based on this we have conditional branch instructions too. So JZ is jump 0, and jump 0. If the 0 flag is set, then it will jump to the particular address being or the loop which is being or the label which is being given. Then JNZ is jump no 0, JS is sign, JNS is jump no sign, JO is overflow, JO and JNO relates to overflow, JNP relates to parity. And JB and JNB related to C carry flag. and CXZ, the flag denotes to CX, which is 16-bit. Then we have the loop instructions. The loop Z and loop E, the loop Z and loop E. Loop through a sequence of instructions from label, while zero flag is 1 and CX is equal to 0. Then the opposite loop N0, that is when it is not 0. Then we have the string manipulation instructions, that is repeat. This instruction is used to prefix to other instructions, the instruction to which REP prefix is provided, which it is executed repeatedly until the CX register becomes 0. So this is a repeat instruction which whenever we want to keep on repeating a particular set of instructions, we'll be using this. Then we have the move SB. S here relates to string. So string manipulation instructions these are. So move SB denotes move string byte, and move SW means it is move string word. Byte is 8 bits and word is 32 bits. So in order to move a string, then other is compass string, CAMPS, then a scan string byte, similarly load strings and store string. All these instructions, yes, all these are used whenever string manipulation has to be done. Then we have the flag manipulation instructions, different flag manipulation instructions. That is, flags can be set or reset, right? So whenever we need to manipulate a particular flag, a clear, we need to clear, we can carry, clear a carry flag, complement a carry flag can be done, set a carry flag, clear direction flag, STD is set direction flag, then clear interrupt flag, set interrupt flag. All these instructions are used to manipulate flag instructions. Next we have, then finally we have the machine control instructions. Wait is a machine control instructions. Then halt is a machine control instruction, which always will be the end of a machine control process, end of a main program. NOP is no operations. So if any pipelining stalls or anything is occurring due to delay in accessing an instruction, or due to delay in a data hazard, due to delay in instruction hazard, if any, due to any such hazards, if a stall is happening in a pipelining, that can be rectified using no operation instructions easily. Then escape instruction is used to escape external device. Then lock instructions is also available in machine control instructions. So we have discussed about all the instructions, instruction sets of 8086 and these three parts of the video. And this is for your assessment. We have two puzzles. Kindly go through it, and thank you.